This is a very exclusive video where you're going to learn everything about how to repair laptop motherboards, including short circuits repairing, how to identify the cause of dead motherboards, how to trace the voltage, the most common fault on a failed laptop motherboard, and of course you're going to learn the components that compose every circuit in the motherboard.
So the first thing to do is a visual inspection. Always when you get a motherboard, you should do a visual inspection, okay? By looking to all components in the motherboard, including ICs, capacitors, inductors. This IC basically is the controller for the RG45. Okay, we have here a crystal oscillator. So over here we have the CPU. This is basically the CPU circuit where we have these inductors. So each inductor means a channel. We have here the first channel, and this is the second channel for the CPU. Okay. So we have here some capacitors. So all these components are good. So basically over here we have the charge circuit, or the DC battery charger, where we have, as you can see, the power jack cable. Okay, so as you can see here we have two power MOSFET. As you can see over here we have two inductors. Basically these two inductors are connected directly to 19 volts. Here we have this red cable means 19 volt. So two inductors, we should basically find here 19 volts. Okay, we have here another MOSFET, we have inductor, and over here we have the battery connector. So let's see the back of the motherboard. So this IC, as you can see, is the controller for the VGA port. Okay, we have USB connectors. This is the USB connector controller here, as you can see. So this chip basically is the BIOS. We have here a pin, means this is the BIOS. So here basically this is the back of the CPU, where we have, as you can see, these four MOSFETs. So these two MOSFETs are for one channel, and these are for the second channel. And here we have, as you can see, the CPU control IC. So its reference, as you can see, is Maxim 1703 OG, as you can see. This is the CPU control IC. So as you can see, then we have here, as you can see, the Super IO. This is basically the Super IO with another BIOS chip over here, because for the BIOS, depending on the type of motherboard, you can find one BIOS chip or two BIOS. Before continue to diagnose the motherboard, I will first explain to you the component of the motherboard, all components, in order to have all components in this motherboard. Because many of my followers ask me to explain the component of motherboards, especially ASIC components. So let's pass quickly and see all components of this motherboard. So let's begin here. So as you can see, this is a connector, okay? Here we have power MOSFETs, as you can see here. This is basically transistors. This is an integrated circuit, a small integrated circuit with 8 pins. Here we have inductors, okay? Here we have another MOSFET over here. This is inductor or coil. Here we have the battery connector. Okay, so this connector is for Wi-Fi card. Here we have a capacitor. This is a polarized capacitor. We called it also a tantalum capacitor. Coil. We have electrolytic capacitor with plus and minus. As you can see over here, we have plus, and here we have minus. Okay, so this color here means minus, and here we have plus. So these capacitors also are polarized capacitor. So coils, this is diode, as you can see. Here we have the cathode, and here we have the anode. We have here D, as you can see. So this white mark means this is the cathode, or the negative terminal. So here we have the RG45 control IC. This is basically RG45 connector, and always near to the RG45 you will find this control IC. So we can check another motherboard, for example. Here we have RG45 connector. We have this key mark IC. Okay? So if you have any issue with RG45 IC, you should check this IC. So this is an integrated circuit. Here we have crystal oscillator. You will find always its reference is X or Y. As you can see here, we have Y, L. This is the resistor. 3 zeros means this is a fused resistor. Here we have a ceramic capacitor. Here we have inductor. We have L. Always L means refer to inductor or coil. So here, as you can see, this is audio port, and next to this audio port we have this IC. As you can see, this is the audio control IC. If you have any problem with this IC, this port will not work properly. So over here we have ceramic capacitors. Okay. Those are ceramic capacitors, and this one is the inductor. Okay, so this black color means inductors, and this yellow or brown color refer to ceramic capacitor. So always pay attention. Do not confuse between ceramic capacitors and inductor. So this is inductor, these are ceramic capacitor, and this one inductor, ceramic capacitors, inductor or coil, and all these are ceramic capacitors. So ceramic capacitors has the purpose to remove the noise in every circuit. You will find always ceramic capacitors in every circuit because they have used to remove noise in circuits. Okay? So those basically are resistors. This is resistors. Here we have another crystal oscillator, as you can see. So those are transistors here. So let's see the other side of the motherboard. So here, this is the VGA connector, where we find 3 inductors. Always next to the VGA connector you will find 3 inductors. If you have any problem with this connector, you should always check these inductors using the multimeter. Of course, using the continuity mode in the multimeter. Okay? And this is the IC that controls the VGA connector. Okay? So here, normally an inductor should be connected, but it is not connected here. This symbol is for inductor. Okay? This symbol is for inductor. So this is the BIOS, as you can see, 8-pin BIOS chip. So always the BIOS will be marked with this, with a pen, as you can see. Crystal oscillator, IC. So tantalum capacitor, inductors, MOSFET. Here also we have MOSFETs. This is basically ceramic capacitors. In the backside of the CPU, this is the super IO, okay, the super input-output IC. And here we have another BIOS chip, okay, with this mark, as you can see. So usually you will find just one chip in motherboards, one BIOS chip in laptop motherboards. But sometimes you can find 2, like this motherboard. So here we have induction, as you can see. This is basically inductors. Here we have MOSFETs. this is diode, as you can see. So as I told you before, this white mark means the cathode and the anode. And here we have transistors, several capacitors, resistor. So now let's go forward and diagnose this motherboard. So we should first connect the power adapter. Okay? So here we have the power adapter. So let's use the multimeter. Let's check first the power adapter and check 19 volts. So let's check the charger first. We have 19 volts, as you can see. So the charger is serviceable. Now let's connect the adapter. Okay. As you can see here, the LED is on. Okay. So this adapter has an LED, as you can see. If any motherboard has a short circuit, this LED will turn off. So let's connect the adapter. So the LED is still on, means we don't have a short circuit. But if you focus here, the LED light is not stable, means we have a problem with the motherboard. The voltage is missing somewhere in the motherboard. Okay? So basically this is the power jack cable. Here this two red cable means 19 volts or the positive side, and here we have the ground. So if we measure between ground, as you can see here, and these two red cables or these two terminals, we should get 19 volt in the multimeter. So let's check. Do you see? The voltage is not stable. We have 19, then 18, 17, 16. Okay? And I hear a click in the motherboard. Means we have a problem somewhere in the motherboard. Okay? Normally the voltage should be 19 volts or 18 volt, 0.9 or 0.8. But the voltage is not stable. That's why the LED flippers. So basically this is the 19 volt part here. Okay, so here we have 19 volt. Then it will goes directly to this inductor and also this inductor, and then will goes here to the other side of this inductor and also this inductor, and then it will goes directly here to this power MOSFET, as you can see. So here basically this is the source of the MOSFET. We have 19 volt, and here we have the drain. We have also, we should get basically 19 volt, as you can see. Do you see the voltage? It's not stable. Okay, we have problem somewhere here. And then let's check this one. Do you see the voltage? It's not stable. And the voltage should be also here, the other side. After that, it will be distributed to all motherboards. So, do you see this MOSFET? So let's check this MOSFET again. So here we have the source. So here we have, as you can see, 18 volt, 17 volt, 19 volt. But in the other side, as you can see, the voltage drops until 1 volt and 2 volt. Do you see? So this MOSFET could be the failed component because the voltage drops from 18 volt to 2 volt and 1 volt. This one could be the failed component. So the problem for this motherboard is somewhere here in the charge circuit or in the DC battery changer. So right now I will remove the power cable or the adapter and check using the multimeter the component here. Okay? So as I told you before, I can easily pinpoint the failed component and solve the problem of this motherboard easily. But I want to explain to you in detail how you can diagnose any motherboard. If you watch this video, you will be able to diagnose and repair any motherboard regardless of its fault. So first, let's put the multimeter to diode mode. So let's check this MOSFET. So here we have source, as you can see, and here we have drain. So let's check. So we get about 0.5 drop voltage. 497, so good. About 0.5 drop voltage. So if we check between gate and drain, nothing. So if we check between source and the gate, we get nothing. So this is basically, we don't have basically no problem here. So let's check this MOSFET. So let's swap the probes. About 570 or 80. So it seems that these two MOSFETs are good, but the problem basically could be here. So let's see the other side of the motherboard closely. Oh, look at that. We have a problem here. Do you see here? Oh, we have maxim. So this IC basically is blow out. We have the maxim. This is basically the charge IC or the DC battery charger control IC. So it's blow out here. We have a problem here, as you can see. So this IC 100% is failed, as you can see here. So let's check the ceramic capacitors around this IC. Normally we should find these capacitors shorted to the ground. So let's check. So always the black probe in the ground everywhere in the motherboard. And let's check these capacitors. So always meter in diode mode. So we get a 700. Here of course is connected to the ground. Okay, here this is the ground. Okay. As you can see basically we have a short. Okay. It should not be 0.42. So we have a short. So here, as you can see, for this capacitor, this side is connected to the ground, and this side basically is connected to the IC. So it should not gives 0.42 in the diode mode. Means here we have a short circuit. So let's check this also. Here connected to the ground. So this is good. So let's check this one. Oh, I have a short here. Look at that. Here also we have a short. So this capacitor is shorted and this is shorted. But these two capacitors 95% are good. This is the failed component. Here it's blown out. So we should replace this.
Here we gonna study basically many circuits. The first circuit, as you can see, we have 3 volt, 5 volt circuit. Okay, so guys, please pay attention. If you understand just how one circuit works, you can understand any other circuit, because the working principle in the computer is always the same. The 3 volt, 5 volt circuit is the same as 1.8 volt, 1.5 volt circuit, the same as RAM circuit, as also CPU circuit, etc. So let's get started. But first, don't forget to subscribe, share and like the video. So as you can see here, this is basically the 3 volt 5 volt circuit. As you can see here, we have plus 3 volt always, and here we have plus 5 volt always. So basically this circuit is the responsible to generate these 12 voltages. So basically this 3 volt 5 volt circuit divided into 2 channels, as you can see. So here we have the first channel, and over here we have the second channel. So always all channels are the same, as you can see, the same component here are here. So let's begin, for example, with 5 volt circuit channel. So we have the IC, the control IC, we have 2 MOSFETs. We call this MOSFET the higher MOSFET, and this one we called it lower MOSFET. And then we have inductor and capacitor. This is basically electrolytic capacitor. And over here we have 3 ceramic capacitors. Okay, so how we get plus 5 volt? So to get plus 5 volt, we need first 19 volt, the main voltage. So basically this 19 volt, as you can see, is of course applied to the control IC, because the 19 volt is the working voltage for the IC. Without 19 volt, the IC cannot work. Okay, so the IC receive 19 volt, and also as you can see here, the 19 volt is applied to the first MOSFET, as you can see. Okay, so here we have 19 volt that will pass through these ceramic capacitors. This is ceramic capacitors. Okay, so basically this ceramic capacitors has the purpose to filter the current or the voltage. It remove the noise in the signal. Okay, so once this 19 volt is here, okay, this MOSFET and this MOSFET will receive the control signal, as you can see here, from this IC, and then 19 volt will pass through this MOSFET. But pay attention, it's not 19 volt. Here we have 19 volt in the drain. Basically this is the drain. We will get here in the source 5 volts. Okay, 5 volt, because this MOSFET basically we called it voltage regulator. Voltage regulator. Okay, so we will get here 5 volts. So the 5 volt will pass through, as you can see, this inductor. This is inductor. The reference for inductor is L, as you can see. Then the 5 volt will go and pass through this electrolytic capacitor. As you can see, we have here plus and minus. So the electrolytic capacitor basically is polarized capacitor. So the purpose of this capacitor basically is to filter the voltage, to make the voltage a continuous voltage. Okay, then we will get here 5 volt. So the same working principle for 3 volts always. So we have the IC, we have 2 MOSFETs, okay, or voltage regulators. Here we have 19 volt that will pass through these ceramic capacitors, then goes to this MOSFET or voltage regulators. Then here we will get 3 volt or 3.3 volt. So the 3 volt will pass through this inductor in order to increase the current. Basically the inductors here has the purpose to adjust the current or to increase it in order to get enough current for the circuit. Okay, then as you can see, the voltage will go and pass through, as you can see, this electrolytic capacitor that will filter the current and then get a continuous voltage. Okay, so this is basically electrolytic capacitors, and over this electrolytic capacitor we have its characteristics. As you can see, 16 volt, 22 microfarad. So what you can wonder, you can ask me, so what is the purpose of this MOSFET, this lower MOSFET that is connected to the ground? Okay, so basically this MOSFET has the purpose to adjust the voltage here. For example, we need to get here 3 volts or 3.3 volts. Let's assume that we get, for example, here 4 volt or 5 volt. So this voltage will adjust the current and eliminate the extra voltage to the ground, as you can see. Okay, so this is basically the working principle of 3 volt 5 volt circuit. Now I have a question. If you have a failed 3 volt 5 volt circuit, for example, you have 3 volt is missing. For example, you check the circuit, you find that 5 volt is here, it's okay, but 3 volt is missing. What should I do first? I should first check whether I get here 19 volt or not. The first step is to check 19 volt. So if I get here 19 volt, if I have 19 volt, then the second step is to check the control signal. As you can see, the control signal that is generated by the IC. If this 2 MOSFET doesn't receive the control signal, the voltage will not pass from drain to source. Then we will not get 3 volt. Okay, let's assume that these 2 MOSFET receive the control signals, but we still didn't get here 3 volt. So we should check whether we have short circuit or not. You should check this MOSFET, all component. You should check in this stage all component that is connected to the ground, including MOSFET. This one could be shorted because it is connected to the ground. This electrolytic capacitor also could be shorted because it is connected to the ground. And the IC also could be shorted because it is also connected to the ground, as you can see. Okay, and of course ceramic capacitors. Ceramic capacitors, if ceramic capacitors are shorted to the ground, you will not get here 19 volts. The main voltage power rail will be connected to the ground and you will get a dead motherboard. Okay, so the same working principle here. So always the component that you should check when you have a failed 3 volt 5 volt circuit are the IC, the MOSFETs in both channels, so the ceramic capacitors and electrolytic capacitors. Inductor, no. The inductor is not connected to the ground. Always the inductor is about 95%. You cannot find a bad inductor. When the inductor is bad, it will be cut because the inductor is just a wire, okay? And the inductor can never be connected to the ground. It is always in the power rail. But you can use the inductor to check whether you have a short circuit or not. So let's go to another circuit. So we're gonna pass to CPU circuit. So as you can see here, we have the CPU circuit, basically the same working principle. We have the IC here, okay, the control IC. So we have here, as you can see, for the CPU circuit, as I told you before, it has usually 2 channels, 3, 4 or more. As you can see, for the CPU circuit, as you can see, we have 2 channels. This is the first channel and this is the second channel. And of course, the output of both channels are connected. Do you see? Here we have plus VCC core. So plus VCC core is the main voltage for the CPU. So basically here we have 19 volt, as you can see. So here we have 19 volt, and 19 volt here will pass through electrolytic capacitor, as you can see. So here we have electrolytic capacitor over here that will filter the voltage. Here basically we have the path. This is the path or test point where you can test and check whether you have 19 volt or not. So the voltage then will pass through 4 ceramic capacitors. Over here we have basically 4 ceramic capacitors. The ceramic capacitors basically will increase the noise. And here we have 2 MOSFETs. Okay, so 2 MOSFETs. Here we have the first MOSFET, as you can see, and over here we have the second one. Okay, and here we have inductor. So let's put the inductor here. Okay, and of course here we have the IC. So this is the IC. So 19 volt will pass through this electrolytic capacitor in order to get a continuous voltage, and then through the ceramic capacitors in order to remove the noise from the signal, and then goes and pass through this MOSFET here after receiving the control signal from the IC. So here we will get plus VCC core. So the VCC core value is usually about 0.35 volt volt to 1.2 volt, okay, depending on the type of the processor, okay. So then the voltage will pass through this inductor in order to adjust the current, and then we will get plus VCC core over here. So the same working principle in this channel. This is basically the second channel, as you can see. So we have ceramic capacitors here. So the 19 volt, of course, will pass through this electrolytic capacitor. So this electrolytic capacitor is common between this channel and this channel, and then goes through this part or this point, and then here, as you can see, we will get also 19 volts. So do you see this bolded line here? We have a bolded line, as you can see, means a high voltage. But here, for example, we have just a 10 wires or path. It means this is basically a signal, just signals like 2 volt, 1.5 volt, etc. But here, this bolded line means 19 volts. So 19 volt will pass through this ceramic capacitors, as you can see, and then goes direct in order to remove the noise, and then through this MOSFET after receiving the control signal from the IC, and then here, of course, we will pass through this inductor, and we will get here plus VCC core, okay, in order to power the CPU, okay. So the same working principle. The components that can be shorted here in the CPU circuit are the electrolytic capacitor, MOSFETs, ceramic capacitors, and IC. Why? Because all these components are connected to the ground. You see here, we have the ground. Here, ceramic capacitors connected to the ground. These two MOSFETs are connected to the ground, as you can see. Okay? If you have a failed CPU voltage, a failed CPU circuit, and you didn't get VCC core, what should you do? You should first check whether you have 19 volt here or not. If you didn't receive here 19 volts, so you should first diagnose 19 volt power rail. If you get here 19 volt, means this capacitor is good, it's not shorted, because we have here 19 volt. This one and this ceramic capacitors and those also can never be shorted to the ground. Okay, if one of these ceramic capacitors or this electrolytic capacitor is shorted, you will never get here 19 volt. You will get a dead motherboard. But if you get 19 volt, then you should check these MOSFETs. You should check whether this MOSFET receive the control signal from this IC. Okay, the control signal. If the MOSFETs receive the control signal and the VCC core still missing, then you should check inductor. Is it good or not? If you check inductor and you find that also this voltage is missing, then maybe you have problem in the processor. Okay, so that's it, guys. I hope that you understand a little bit about motherboard circuits. So thank you very much. So please don't forget to subscribe, share, and like the video. Please like the video because your likes motivate me to create more and more videos for you.